Hey students, this is a review of our lesson from Wednesday. It was CCA lesson 312. How can we rewrite it? And we were focusing on negative integers and the zero integer. So let's get started and take a look at what you may or may not have figured out from Wednesday. So our target was we're going to deduce the meaning of x to the 0 and x to the -1 and keep using those laws of exponents. Important to remember what we had done the day before, where we said that if we have a multiplication of our bases, we can add the exponents. So these two would be y to the 6th. And then here, if we have a power to a power, we multiply. So this would be x to the 6th, then y to the 3rd. All right, so let's get right into this. Here's some examples. If you didn't get a chance to do this yet, I want you just to pause this for a second and then come back. So here we are on slide 3. Remember, the ideas behind each of these is I want to be able to say that if I multiply the bases, we add the exponents. And so the simplification of this is x to the 12th. All right, if you type that in, you should get a check mark. Remember, you want to use Shift 6 to use that little caret to get that to work. Right, x to the 3rd, this is the power where we say that means we multiply the exponents, and this should be x to the 9th. Here, this is the quotient rule, where if we have the same bases being divided, we subtract the exponents. So that's 14 minus 2. We get m to the 12th. Here we're taking the power of 2 exponents, so that's going to be a multiplication for each of those. So we have 2 times 4 and 2 times 4. And so we get x to the 8th, y to the 8th. You can go back to yesterday's lesson to look at that a little more in depth. Here we have the quotient rule. What you're going to see is if I subtract 2 minus 5, we're going to end up with a negative number. So x is to the 2nd power minus the 5th power, and y is to the 11th power minus the 3rd power. And we get x to the -3, y to the 8th. We would like to rewrite these without negative exponents, and so if you remember, and we'll look at this a little bit more later, it's x to the 8th over x to the 3rd. Okay, and finally this last one, where we have a constant 2 and a constant 8. I like to separate those out when I think about them. So I have 2 over 8, and over here I have x squared over x to the 2nd. The fraction 2 over 8 reduces to 1 over 4. X to the 12th over x to the 2nd is x to the 10 minus 2, and that's going to equal 1/4 x to the 12 minus 2, so that's x to the 10th. If you type that in there, you're not going to get the check mark. This wants you to write it as x to the 10th over 4 if you're concerned about getting the check mark in there. I just want you to know it. So here we are in slide 4, and we're going to look at these rules to generalize them. And so the idea is I have an expression, I have the generalization, and how do we simplify the generalization? Well, remember, if we multiply the same bases, we add their exponents. So x to the m times x to the n is x to the m plus n. If I divide the same bases, we subtract the exponents, and when I take this power to the power, it's x to the m times n. So this is where you need to make sure you have these 3 rules down concretely. All right, I paused it and made sure that I had this spelled correctly. Erase that. Quotient is Q U O T I E N T. All right, QUOTIENT, the quotient rule, and this last one is our power rule. pause it, please. So the idea here is we know that anything divided by itself is equal to 1, right? And so we have x to the m divided by x to the m is equal to 1. Well, the quotient rule says that we can subtract those, and so we could say x to the m minus m, and anything subtracted by itself is 0. And so what we're trying to discover here is that x to the 0 power is equal to 1. And in fact, any exponent, any base that we have, if I had b to the 0, it's 1. If I had 32 to the 0 power, that's 1. If I have smiley face to the 0 power, that's 1. So let's move up to slide 7, and let's use this idea of x to the 0 is 1. Now we're going to look at how to find negative exponents. So if you look at this first one that's been done for you, you see that we have x to the 4th over x to the 5th. Think, if it's x is on top, x times x times x times x, and 5x is on the bottom, x times x times x times x times x, okay, how many x's are left over when we divide? So let's grab that. And let's write this out. X times x times x times x over x times x times x times x times x. Well, as we've been doing, we know that we can divide each of these and make a 1, and we're left with 1x in the denominator. So that's really how we get this fraction 1 divided by x. Well, if we use the quotient rule, right, we can subtract 4 minus 5, and that's how we get x is negative 1. And so what we see here is that these two are equal to each other, right? 1 over x is equal to x to the negative 1. If we keep going, right, this idea is we'll have 2 x's left over on the bottom, x to the 2nd power, x times x. And if we subtract them, x2 minus the 4 gives us x to the negative 2 power. This x to the negative 2 power is the same as saying 1 over x to the 2nd power. Keep on going. Try this one on your own. Pause. Right. Now when you come back here, I'm hoping you have 1 over x to the 3rd power, and in this box it's equal to x to the negative 3. One of the things I really want you to understand about this too is having a negative exponent does not mean it's a negative number. For example, if I have 2 to the negative 2nd power, remember a negative exponent is going to turn this into a fraction with 1 over 2 to the 2nd power. We'll keep practicing these examples. But what is 2 squared? Well, 2 squared is 4. So 2 to the negative 2nd power is the fraction 1 over 4. So again, a negative exponent does not mean a negative number. Think about what that might mean. So here we are on slide 8. I want you to try out each of these. Okay, take a moment and we'll come back and we'll look at them. Take a look. Hopefully you pause the screen. You're taking a look at it. I'm going to copy this, make a little copy for us. There it is. All right. So m to the 0, we had just said anything to the 0 power is 1. Again, that happens because I could say that's m to the 5th over m to the 5th, or any number, and that quotient rule says m to the 5 minus 5 is m to the 0. Well, remember, anything divided by itself is 0. This second one, just because there's a negative number there, doesn't mean that we can't use our product property. X to the negative 2 times x to the 5th. We can add the exponents, so negative 2 plus 5. If I have negative 2 and I move to the positive side 5 spots, I'm at x to the 3rd. This one, it wants us to say, well, what could this be as a negative exponent? So 1 over p squared is the same as saying p to the negative 2. So when that p squared comes to the numerator, the sign of the exponent changes from positive to negative. Same idea here. I'm going to show you, we're going to move the y to the negative second to the denominator and the y to the negative third to the numerator. And when they switch places, their signs change. Okay. Then we can say, oh, how do I simplify this? Well, we can use the quotient property, which says y to the negative 3 minus 2 is y to the first power. We wouldn't have even needed to switch them before we did that. We could just say y to the negative 2 minus a negative 3. We all know that subtracting a negative is adding a positive, so negative 2 plus 3 also gives us y to the 1. Here our power rule, we just multiply our exponents. We have y to the negative 2 times 3, which equals y to the negative 6. If I wanted to write that without a negative exponent, remember, we would move it to the denominator, so we could have 1 over y to the 6th power. This is a negative exponent, right? It's also a power property, so we could do this in 2 different ways. We could first multiply both of these by negative 1, or we could just write it as a fraction, 1 over a squared b. All right? And so this would be a way to write it. If we multiply that negative 1 through first, we would have a to the negative 2, b to the negative 1. And then we could switch both of them to the denominator, a squared b. All right, 1 over x to the negative 1. Remember what happens when we move that variable up to the top? The exponent changes signs. So this is the same as x to the first power. But we don't need that 1 if it's just the first power, so we could just write it as x. All right. If that went too quick for you, go back and play it again, walk through it, email Mr. Winter a question about one of these specifically. And now you're going to finish up this lesson by doing this card sort. All right, so I'm going to give you a chance to do this on your own. Come back and you can match them. I like to put all the monomials on one side, so you can see all the ones that have only one piece to them on the one side, and then I put all the ones that look like they're a combination of powers to the left side. That way it kind of helps organize it for my brain. I went back and I didn't get them all sorted yet. Sorry about that. So I'm going to look for any of these that ring a bell to me. So this looks like x to the third power to the fourth power, so that's a power to a power. Those two are going to match. Again, if you want to make sure you got one right, you can click on the next screen. I have 2 cards sorted correctly, so since I've only done 2, I know I have those 2 correct. All right, so I'm going to want you to try this out on your own, and then come on back here and see if you did it, okay? All right, hopefully you're able to match these all up. Take a look and walk through them. When you do finish that, remember you should get these little fireworks at the end. So, one more time, you can pause, take a look at each of these and why they make sense. Let's see, this one was giving me a little difficulty. Where was it? This one right here. That's 64 x to the 9th. So x to the 9th divided by x to the 8th is just x. 64 divided by 64 is 1. All right, hope this was helpful. Again, try it out. If you finish these slides, send an email to Mr. Winter to make sure you get credit for your work in this.